This video is on the objective distinguish between use cases of the chi-square tests. And this is the second video on this. I'm hoping you at least watched the first one where I went over all the three different scenarios, the three different kinds of chi-squared tests that you're going to be running. There's a test for independence, right? Are two variables independent or two factors independent of one another? There was a goodness of fit test, where you're going to be testing if the distribution of your sample, if your population's distribution fits a certain known distribution, like a uniform or a normal. And then there was the test for homogeneity, where you have two groups, two samples coming from two different populations, and you're going to test whether or not those populations have the same distribution or not. All right, so again, I hope you've watched the first video, because I'm just going to go right into it. Now, if you want to see the instruction again, click on More Instruction, look at their notes, their videos, their examples, and hopefully those help you out. Okay, so we're asked here, in which of the following situations should the chi-square test for goodness of fit be used? So again, that goodness of fit test is for when you're trying to determine if your sample's distribution fits a certain known distribution, right? Fits a uniform distribution, or if it fits a normal distribution or whatever. So let's read through these and see if we can figure that out. So the first example, first option. An online research company puts out a survey asking people two questions. First, it asks whether they buy groceries online. Second, it asks whether they own a car or not. The data are collected and recorded in a contingency table. The company wants to determine if there's a relationship between buying groceries online and car ownership. Alright, so this would be an example where I'd be running a chi-square test for independence. Right? You're trying to determine if two factors or two variables are independent here. Buying groceries, that factor. Do you buy groceries online or not, versus car ownership? Right? Do you own a car or not? Are these two factors related? Are they independent or not? So you'd be running a test for independence here. So that's not it. Second one. A researcher is trying to determine if the amount of time children spend watching television has the same distribution for boys and for girls. All right, so right there, I can tell you this is a test for, we'd be running a test for homogeneity here. Because I'd have the group of boys, the distribution of boys, and the distribution of girls, and then test whether or not those distributions were the same. So this should be running a test of homogeneity. So it's got to be this last one. Let's see. A professor is trying to decide if her students randomly guessed on a certain multiple choice question, or if they had some idea of the correct answer. She records the number of students that answered with each answer choice, and compares this distribution with a uniform distribution, which is what she would expect if everyone had guessed. So she's comparing the distribution of her class, to a uniform distribution to see how well it fits. Right? This would definitely be the case where you're running a goodness of fit test. So I'm going to select that one. And again, when your hypotheses would be, the null hypothesis will always be that they do fit, that it does fit the uniform distribution. And the alternative would be that it doesn't fit, and then you'd run your test. And again, we'll get into how to run these tests in later videos. Okay, great. And then again, please read your answer explanations. So again, hopefully, listening to me here, looking at my other videos, looking at more instruction, reading your answer explanations when they come up. I'm hoping all this stuff helps you out when you're working on this material on your own. And thank you very much for watching.